So in this video, we will overview this kit and installation into the printer. This particular kit is for a FLSUN V400 3D printer. It contains all the components and cables necessary to add two separate LED strips into the V400. The strips are here, 45 LED strips, two of them attached to the two of the upright rails. That's for lighting effects, status, and lighting the printer for video time-lapsed applications. Now the kit will be broken out separately, so you can just buy the controller board, which is here, the power supply, and the cable separately, so you can source whatever components you want to source yourself. The power supply is available on Amazon, and we'll put a link to that. The enclosures you can print yourself and will be up on printables, so you can print those yourselves. Again, the board allows temperature controlling of the fans. Typically, we like the Noctua fans, the 12 volt pulse width modulated speed control fans with speed readout. That's the ones we typically use. Again, those are available on Amazon or directly from Nocturna, so you can purchase those separately. Those won't be contained in any kit, though. So the controller board itself enables control of the two LED strips and two temperature-controlled fans. What's flashed on the board is a custom user mod of WLED, which extends the basic user mod to allow control of two separate fans. So let's get started with putting the kit together. First, you put it together, and then the second part of the video will be how to add it to the printer itself. So I'll overview the components. Again, you have the LED strips, the cables, the DS1820 Dallas temperature sensors. So the first thing we'll do here is assemble the controller board. Now, let me just zoom in here on the controller board. So the controller board has 4 output ports. 2 of those will be for the 2 LED strips, and 2 of these will go to 2 of the pulse width modulated controlled fans. This strip here is for the DS1820 sensors. There's a power input, which powers both the LEDs and fans. Now, each kit will come in 2 different voltage versions, whether you're using 12 volt fans and 12 volt strips. For example, in this case, the WS2811s or the 5 volt Nocturna fans. Noctua fans, I'm sorry, and for example the WS2812 strips, the 5 volt version. Of course, that's the ESP32, and coming off that is a D1 Wemo style header. You also have a USB-C port here, which you can reprogram the board through if you'd like to do that. So let's get started. Let's zoom out here a little bit. So the enclosure has a notch here, that's the side that goes on the USB-C ESP32 side, so that's just placed in there. And the cover is, again, has a similar notch here, which is placed on that side. We then have M2 screws, which hold the case together. I'm just going to put in one for the time being. Tighten that down. Normally you'd put in all four, but we'll just do that for the time being. Set that aside. Now, we have a separate power supply, whether it's for a 12 volt application or a 5 volt application. This is powered directly from the line in on the printer, the 120 volts or 220 volts if you're in Europe or other countries. This power supply has the line side here and the low voltage side here, either the 12 volt or the 5 volt supply. So first of all, what we want to do is add the cables, the line voltage cables, which will connect to the power receptacle on the printer. And we'll go into that in the second half of the video. So this side right here is, let me get my glasses, the AC side. This is AC line and AC neutral. So keeping with convention, we will add the blue cable, which is the AC neutral, and we will add the black cable, which is the AC line, and screw down those terminals. Next, we will add this cable, which comes in the cable kit. This is the ground side. This is the either 5 volt or 12 volt side. So we'll place black into the ground side and red into the voltage side. Screw that guy down. All right, make sure they're secured. And then we'll add the power supply board into the enclosure. This has markings on it. You can see that, the ground and VDC plus. That will, again, go on this side over here. The other side is marked with the AC line and the AC neutral. You can see that there. So again, just flip it over. And you can screw in the 4 screws that, if you purchase it from us, the enclosure, it comes with the 2mm screws. So normally you'd put in the rest of the 3 screws. How we attach these into the printer is using this 2-way micro style tape. This stuff is very strong. Once it adheres, once you apply pressure to it, literally never comes off. This is, again, available on Amazon. We'll have a link to that. So normally you'd put a piece on the back here. Okay, don't strip off the one side of the tape yet. For example, you'd cut that and leave the film on that until you're ready to put it into the printer. And I just have a used piece here that I'll just put on for demonstration. Add that to the printer. The stuff is, well, generally reusable also. So just add that to where the power supply, the barrel jack, is here on this side. Just stick it down, supply a little pressure, and it won't come off. And then take this and plug in the barrel connector. So this is all set, ready to be installed into the printer. Next, we'll take the relay. The relay in the kit comes without the pins attached, so you're going to have to solder the pins on. We provide extra long pins with that kit, which enable it to be inserted into the D1 WeMos header on the ECB board. Okay, so first we're going to add these two cables to it. This is the relay, switches on and off the 24-volt supply so that you can turn the 24-volt supply and the entire printer off through the controller board here. Again, this will stay on. Again, it's a ESP32, so it doesn't draw very much current. So we will take the side with the fork, which is actually connected to the 24-volt printer. Sorry, 24-volt supply on the printer, and insert that in. And you want to look and make sure it's on the normally on side, which, if you can see, that is labeled ON for normally on. The other side is normally closed. And the center tap of the relay, we'll add the cable with the spade terminal on it. And tighten those guys down. Snug them up. Not a lot of torque. Okay, and then this gets added to the WeMos style header. It's pretty much self-aligning with the holes in the enclosure, but you can feel it down in there and just push it down in and it'll stay. Okay, so other than that, you're ready to install it into the printer. Now, the DS sensors, one will actually go into the power supply with the associated fan that's in the cover of the power supply. Again, on printables, we'll have the printed version of the cover for the power supply, which allows the fan to be integrated into the supply. And the other guy will be placed in the channel of the printer. Specifically, if you're enclosing your printer, you want to be able to maintain the temperature. So this will allow the fresh air to flow into the chamber to control the temperature for various printing applications, various printing materials, I should say. So these guys, this is a KK style Molex header, which is the header on the board. These plug into typically into the first two. It's all reassignable within WLED, but typically we add those on like this. And this isn't done until you install the module here into the printer. And of course, if you have two fans, those are also plugged in here. The first fan, and the second fan. Just align these little tabs here to the inside of the board, and those fit right in. Again, these won't be connected until you put the module into the printer, but you have your sensors here. Those just slide in. Oops. Actually, these are backwards. On this side, just make sure when you put these in, you have 3 sets of terminals here, and they go red, yellow, and black for ground. So the next one would actually go in as red, black, and ground. Let's put those in through the enclosure top, tighten those guys down. So we're all set. Basically, that gives you control of the two LED strips. Let me just zoom out a little bit. Control of the 2 LED strips. And temperature sensing and control of the 2 fans, one being in the power supply, one being in the enclosure. Also, turn on of the main printer through this relay, and we're all set. We've reinstalled the power supply with the printed cover. This is a design that someone made up on printables. We took that and modified it, adding a holder for the DS1820 sensor and a hole coming out for the sensor and the fan. We've also installed the 12-volt supply with the ESP controller board, ESP32 controller board. I'll call that the ECB from now on. And the relay with that, which switches the 120 volts. So let me zoom in here. The first thing we want to do is disconnect these wires. Now, this connector is, this side over here is where the plug comes in. We have the AC line, AC neutral, and this is the switch portion, which is the AC line and the AC neutral. That's switched. We're connecting it so the 12-volt power supply stays on. The switch has no effect on that, although it still has an effect on the main printer power supply, the 24-volt supply. So the first thing we're going to do is pull off the line going to the 24-volt power supply. Pull that guy out of there. I'm going to disconnect the AC neutral going to the supply temporarily. Then we're going to pull off these two jumpers, the neutral and the line. Then the wires that come with the kit that we've previously connected to the 12-volt power supply. This is the blue is the AC neutral. We're going to connect it to that tab, and you know, sometimes you need to use a pair of needle nose pliers to get those on. So this one is going to go here, and the neutral side of the plug terminal. Then we're going to hook up the AC line side from the switch in the back to the plug side. Okay. So again, the black is the AC line going here and here. Really, the orientation doesn't matter that much with the AC. It's just a matter of keeping, you know, neutral and line, you know, corresponding. You know, on the switch, because this stays on, this is connected to the line, this is connected to the switch. So we're going to take the AC neutral that we disconnected, put it back on that terminal, the AC neutral, and then we're going to connect the AC line terminal of the switch, and that goes to, let me zoom out here, zoom over a little bit. That goes to the relay on the ECB. And we'll get that tight with the needle nose. And then we'll take the other line coming off the relay and connect that back to the I can get it in there. This is always fun. All right, that's good. Good enough for show right now. All right. So we'll just push those up, get them out of the way. Let me zoom out here some. Next thing we're going to do is hook up the 12-volt LED strips to the ECB. Again, we have these cables, extension cables. As you can see, the LED strips pigtail is there. Align the connector accordingly. Plug that in there. Go up to the first connector. Now you want these tabs here facing out. When you put the connector on, just push it up in and it's connected. The other one over here, the 12-volt LED pigtail will plug into the JST side, and with the two ridges out, we'll plug into the ECB. All right. The last thing you do is hook up your fans to the next two terminals on the ECB. That's the power supply fan, and we don't have it installed on this printer, but if you have a fan in the enclosure or up on the top of the printer, that would be connected to the fourth connection. The last thing we're going to do here is connect the Dallas sensors to the board. The 3.3 or the red is on the right, the signal in the middle, and the ground is on the left. We're just gonna stick those guys in. And if you get the connectors from us, we put these ferrules on. If not, just make sure the wire's soldered so it's stiff, so you can insert them into the hole. Again, the next three: power, signal, and ground. And let me get my screwdriver, a little small Phillips, number 1 probably. Just go up through the hole, cinch those down. Don't have to use a lot of pressure, just so they're snug. All right, you can tuck those back in. You can maybe put a tie wrap here to hold that down, but essentially we're done. Once you've wired the ECB and appropriate supply into the printer, you can plug it in and go to WLED ECB1.local and bring up the user interface. As you can see, we've programmed in the configuration, the segment, and presets: booting, heating, idle, mesh, off, on, pause, and printing. Under the configuration, those LED preferences are pre-programmed in. And of course, this is a custom user mod for 2 temperature controllers and 2 fans. So we have the temperature controllers on pin 27, the pins programmed in for the pulse width modulated fans, and the tach go off of them. And target temperatures here, we have 28 degrees C and 26 for the second temperature sensor and fan. Those come pre-programmed on the board. And come over to info, and the printer was just running, so the temperature of the 24-volt supply is 31 degrees C. The fan is currently running at about 2900 RPMs. Normally, if it's been off or sitting, that'll sit at 0. So the next part of the configuration is for on the FLSUN speeder pad V400. So we can go to this isn't currently enabled. What we have to do is turn the printer on, and let's bring up the video of the printer here. So we can either use Alexa. This is all standard WLED stuff, but in this case we can say, Alexa, turn on V400. So that'll come up with the default or the initial flashing, which is preset 1. Currently you can make any color you want, any pattern you want for this. This is when the speeder pad is booting up and the printer is powering up. So give it a couple seconds and it'll go to a slow flashing blue. So now the speeder pad is up. So we can come over to the speeder fan here and configure that. So in two files you want to configure is moonraker.config, and you want to add this section here, WLED ECB 1. These files will be up on GitHub, so you can just either replace them in your printer or cut and paste them into your configuration. So you just, in moonraker.config, you just need to add the instantiation of the WLED. And the other configuration here is in printer.config. And you need to add this section for WLED control. G-code macros for WLED on, WLED off, WLED control, power on, WLED set, and these G-code macros which define the corresponding presets. Preset 2 corresponds to preset 2 over on WLED. So that's pretty straightforward. It's just a cut and paste into printer.config and Moonraker, this section here. The other thing you need to do is in your slicer, in this case Cura, under your printer configuration, just want to go to manage printers, printer settings, and for the start G-code section and end G-code section, right before your heating commands, just put in heating WLED, which again corresponds to the G-code macro, which is called heating WLED. Corresponds to this here. Let's get rid of this guy. So we have heating WLED here. Again, these will be up on GitHub. And at the end of Start G-Code section, Printing LED. And End G-Code section, we just have an idle WLED here, G-Code macro. So you can just slice this guy. I've already sliced it, so I'm going to just upload it to the V400. Upload. And let's get rid of this. Go back to WLED. So then we can start a print. Go to the dashboard again. Select the G-code file we just updated and hit print. So the LED is going to turn red for the heating WLED preset. Again, you can look at info here and see the temperature of your supply and the temperature of your enclosure and the corresponding RPMs on your fan for each one. So this will take 30 seconds or so to come up to temperature. And you can see the temperature on the power supply, the 24 volt power supply is ramping up, as well as the fan speed. Nice thing about this is, you know, if your printer's sitting for a while, again, your fan speed will basically go down to 0, reduce power consumption, fan wear. So it's printing now, and the LEDs have now switched to the printing LED preset here on WLED. If you're using time-lapse, you can also change the time-lapse configuration file to turn on. For example, we can hit a preset. Actually, you can do it from either WLED or from this user interface. But the G-code macros are available here. So you can hit WLED on, for example, if you want it full white. Or go back to the printing WLED preset right here. So each time it completes a layer and the time-lapse config fires, it'll turn on the lights to white. And we'll switch them back to green while it's printing. Actually, with a little more logic, you can program in a WLED progression, so you could, turn on the lights according to the progression of the print. Again, these presets here can be changed if you want to change, printing WLED to whatever. If you want to change it to, let's do a colorful under WLED. You can do that. So pretty much any lighting pattern you want is possible. Showing print progression, turning on white lights for the time lapse. So the print's about 56% done. We'll just let it run out here. So it gives a good visual indication of when your print completes. The settings, the lights are totally up to you what you want to program in. But again, the user mod here is you have control over 2 LED strips, however you want to place them in the printer. Here we have them placed on the front rail, so it's shining back, so you can use the time-lapse camera, light your scene, light your print, whatever colors you want. And again, you can do the mod on the printer to have a temperature controlled fan on the power supply and a temperature controlled fan on an enclosure if you enclose your printer in an enclosure. So we're 96, 97% done. So once it completes, it'll go back to the idle state. Which is the slow blue flash. And we have a 30-second, or rather short timeout on the printer. Typically, you'd make it 5 minutes or 10 minutes. In this case, it's 30 seconds. So after 30 seconds, the printer will power off. Or if you want to, you can say, Alexa, set V400 to green. So it's fully voice controlled via Alexa. Alexa, set V400 to red. Actually, it just powered the printer off there. Now, some people say you shouldn't power your speeder pad off like that, but nonetheless, unless you're saving files explicitly at a time when it powers off, there's no implication of file corruption with the speeder pad. So that's basically it. That's how you set up. Well, WLED is set up in a preliminary fashion. How you modify it. How you then configure your FLSUN printer. In using the configuration moonraker.config and printer.config and timelapse.config if you're doing time-lapse. And that's basically it.